Right, dear students, I welcome you to revisionug.com, the e-learning platform that provides education in its simplicity through using video tutorials and offering organized notes, easy to read, understand, and quizzes plus questionable tests. Follow us using these links below. In this lesson, we are going to discuss molarity. Molarity of a solution refers to the number of moles of a substance in 1 liter of that solution. I repeat, molarity simply means the number of moles. We have the word molarity. This one comes from the word moles. So when we look at molarity, it is always molarity of a solution. So when we form a solution is formed when we have a solvent plus a solute. So if our universal solvent is water, then plus a solute, let us say it is sodium chloride, then we are going to form a solution. Now, how many moles of sodium chloride are in this solution? Then that's what we are referring to molarity. But this sodium chloride solution must be up to 1 liter. So in 1 liter of a solution of sodium chloride, then how many moles are there for sodium chloride? So therefore, in simple terms, we define our molarity of a solution as the number of moles of a substance contained in a solution, and this solution makes up 1 liter. So that is molarity, and this molarity is measured in units that are moles per liter. Or we can take this molarity in terms of concentration and we measure it as moles per we can change these moles into mass and we measure that one as grams per liter. But basically molarity is measured in moles per liter. Then molarity is denoted by capital M. So always when you find this one, it is molarity. I can write 2 molar. Now this one means that my solution in 1 liter, I have 2 moles of a certain substance. So we have also another term before we get started, which we are going to look at, and this is what we call a molar solution. A molar solution here. A molar solution. So a molar solution refers to a solution whose concentration is known, and this solution is made up of only 1 mole of a substance. So a molar solution is a substance that contains a molar solution is a solution that contains 1 mole of a substance. For example, I can say 1 molar of sodium chloride aqueous solution, meaning that this solution I have, it is made up of 1 mole of sodium chloride. So that solution is what we call a molar solution. So a molar solution is a solution which is making up or which contains 1 mole of a substance. Then we have what we call a standard solution. So what is a standard solution? So a standard solution is a solution whose concentration is known. I can say this solution I'm having in this beaker, it is 0.2 molar, meaning that this is a standard solution. I know its concentration, I know the number of moles of a certain substance that has been put there, so that one becomes a standard solution. My dear student, are we still together? We started by defining molarity, and we've said that molarity refers to the number, or molarity of a substance of a solution refers to the number of moles of that substance which has been used to make a solution, and the solution has been made up to 1000 cubic centimeters. Then if we make a solution and it is containing 1 mole of a certain substance, then that solution is called a molar solution. And again, if we have any substance, any solution, and its molarity or its concentration is known, then the substance is called a standard substance. Then we have what we call a primary standard. Then a primary standard, that is the substance whose concentration is known and is going to be used to prepare a standard solution. Alright, so with those brief notes, clarifications, let us get started with what we call molarity, because this molarity involves more of calculating. So remember, as I stated earlier, the notes are down below the video plus some simple tests there. Now let us get started with our first example as we understand what the word molarity means. Then the first question says 2 grams of sodium hydroxide dissolved in water to make a 200 cubic centimeters of a solution. Calculate the molarity of a solution formed. Now, my dear learner, there are 3 things which we are going to follow when we are dealing with molarity. 1, we have to know or to remember the idea of conversion. Do you still know how to convert? Conversion of units, right? From senior 1, from physics, we've been taught how to change from kilometers to meters, meters to kilometers, hours, and so on. So in chemistry, we are also going to apply that knowledge here. But for us here, we are not going to play with meters, kilometers, we are going to play with what we call moles and grams. So in our laboratory, we have a unit of measurement, and that unit of measurement is called a mole. So in simple terms, not going into details, a mole simply means a unit of measurement. So a mole is a unit of measurement in a laboratory. So just like when you hear kilogram, gram, and so on, so we can change moles to grams or grams to moles. So we have to remember the idea of conversion. And number 2, we have to be well versed with the chemical formula of the compounds given. So the chemical formula of the compounds given. And number 3, we have to keep in mind what we call the relative formula mass, how to calculate the relative formula mass. Now, my dear student, let us get started. So from our previous sessions, from senior 1, from primary, we have what we call leading statements, and these leading statements, they guide us how to convert from one to another. But now in chemistry, our leading statement which we are going to use says that 1 mole of a substance, 1 mole of a substance is equal to its RFM. So we have to put this one into our minds. That worries when you look at 1 mole, that is equivalent to its relative formula mass. Now we are going to use this one. Let us now come back to the question. They are telling us that 2 grams of sodium hydroxide dissolved in water to make 200 cubic centimeters of a solution. Now, what is the molarity of a solution? Molarity, what does it mean? They are asking us how many moles are going to be there if we make that solution to 1 liter. But right now they are telling us that 200 cubic centimeters, they contain 2 grams. But remember, molarity deals with the moles, so there is a conversion from a mole to a mass, right? But let us start with what is given, then we are going to convert later on. So we are going to start saying that 200 cubic centimeters here, 200 cubic centimeters of a solution, and the solution contains sodium hydroxide is equivalent to, it contains 2 grams of sodium hydroxide. Then how about if we make it to 100 cubic centimeters, that is a liter of a solution, as they are requiring to get molarity. So this is 1000 cubic centimeters inverted L out of 200 cubic centimeters, then times 2 grams of the sodium hydroxide, then cubic centimeters off, then 2 zeros off this one with this one, then by 2 1, then by 2 a 5, then 5 by 2, that is 10 grams of sodium hydroxide. But a question did not ask for the mass. No, the question asked for molarity. Remember, we say that molarity refers to the number of moles, and the moles in a liter of a solution. Therefore, after getting the grams, now we are going to convert grams to what we call moles. And how do we change grams to moles? Then we said we are using our leading statement that says that 1 mole of Now 1 mole of now our substance, which is sodium hydroxide, is equivalent to its RFM. Now we don't know its RFM, but we know how to calculate the RFM. So sodium is 23 and oxygen is 16, hydrogen is 1. My dear student, don't cram these ones. These figures are given even on a question paper. Therefore we substitute in, that is 23 plus 16 plus a 1. So when we add 23 plus this one, that is 39. Then 39 plus 1, that is 40. Therefore, from our side work we shall say 1 mole of the sodium hydroxide is equal to the 40 grams, now the RFM. Then we are going to convert the grams here. So the leading statement is going to change and say 40 grams of sodium hydroxide represent or contain or produce 1 mole. Then how about if we have 10 grams in 1 liter, in 1000 cubic centimeters? Then 10 grams of sodium hydroxide will now give us 10 grams inverted L from here, go up here, that is 40 grams, then times 1 mole here. Then a gram with a gram is 0 by 0, we have a quarter, and this a quarter is same as 0.25 moles. Therefore we come and conclude and say, therefore the molarity of sodium hydroxide when we use 2 grams and we make it to 1 liter is 0.25 moles per liter. Remember, they were asking for molarity. All right, let me think that we are still together over there. Let us get another example here. Okay, our example number 2 says, what is the mass in grams of sodium carbonate 10 water is contained in 50 cubic centimeters of 0.1 molar solution. Remember what I said, when you see this M, this one must be capital. When you see this M, this one stands for molarity. Before going into any other thing, you have to first give the interpretation of this. This means that in 1000 cubic centimeters of a solution, there we have 0.1 moles of which substance? Of sodium carbonate bicarbonate. This one decahydrate, sorry, it has 10 water molecules. It is a water of crystallization. So that's what I told you at first, that you have to be well versed with writing the formula. Now, so we have this one. Now they want us to convert. If now how many moles are we going to have in 50 cubic centimeters? So how about the 50 cubic centimeters of a solution containing the sodium carbonate? So this will be 50 cubic centimeters over 1000 cubic centimeters, then times 0.1 moles. Then cubic centimeters will go, we have 0 by 0, then 5 1, then 5, it is a 20. Therefore this is giving us a 20th times 0.1. So on our calculator here, it is 1 divided by 20, then the answer is, then multiply it by 0.1, then we are getting a 0.005 moles. Then after this, they are telling us that now we convert this one into mass. Our leading statement says 1 mole of a substance, that is now a sodium carbonate water, 10 water, is equivalent to its RFM. Now we don't know its RFM, but we know the formula. Now let us get its RFM, sodium carbonate decahydrate here. So we have 2 sodiums, sodium atoms, then plus 1 carbon atom, then plus how many oxygen atoms? Then plus 3 oxygen atoms, plus 10 water molecules. Now 2 times 23, because sodium is 23, then plus carbon, which is 12, plus 3 times 16, which is oxygen, then plus 10 into 18. And where is this 18 coming from? That is water. OH with their 2 hydrogens, that is 2 plus 16, that is hydrogen is 1 then 2 plus 16, that is 18. Now this is going to be 180 obviously. Then we are having 16. We are having 16 times 16 times 3. What are we getting? We are getting 48, right? Then 48 plus 12, then plus 40, 6. Let us add this. Then 48 plus 12 here, then plus 6, then again plus 180. So my calculator is giving me 286. Therefore this is the grams. This is the RFM. Therefore this means that 1 mole of sodium carbonate decahydrate, 1 mole of sodium carbonate decahydrate is giving us is same as 200 or produces 286 grams. Then how about 0.005 moles that are contained in 50 cubic centimeters? We are going to get 0.005 out of 1 mole, then times 286 grams. Then a mole will go with a mole. Therefore we are multiplying 0.05 0.05. Let me first clear my calculator. Now 0.005 times 2, 8 and 6. Then the answer is 1.43 grams. Therefore we come and conclude and say then 1.43 grams of a sodium carbonate decahydrate contained or is contained in 50 cubic centimeters of 0.1 molar solution. Right. Okay, now let us get another example here. Now this example is very simple. It says the molarity of potassium hydroxide. Remember I told you we have now to know what does the word molarity mean and how do you write potassium hydroxide. I think that's your game. So potassium hydroxide, this is how we write it. Then they are telling us that its molarity is 0.01, and the word molarity means the moles in 1000 cubic centimeters of a solution, and that solution is containing or is made using potassium hydroxide as our solute. Therefore this statement automatically we are going to first put it into interpretation. That is 1000 cubic centimeters of a solution contains 0.01 moles of potassium hydroxide. Then they are telling us that calculate the concentration of potassium hydroxide in grams per liter. Now in grams per liter, it means that we convert these moles per liter, this molarity per liter, then we take it to grams. That is very simple. Then how do we change moles to grams? That is using the RFM. That is the leading statement says 1 mole of now potassium hydroxide is equivalent to its relative formula mass. Now let us get its relative formula mass here. That is potassium, then plus oxygen, then plus hydrogen. And potassium from here they have given us 39, so it is 39, then plus our oxygen which is 16, then plus our hydrogen which is a 1, then 1 plus 39, that's 40, 40 plus this one, that is 46. So they are 46 grams, meaning that 1 mole of potassium hydroxide weighs 56 grams, right? Then how about now the 0.01 moles of potassium hydroxide? We are going to get 0.01 moles out of 1 mole times 56 grams. Then mole goes with the mole, therefore let us multiply this. So this is 0.01, right? Then times 5 and 6, what we get? It is 0.56 grams per liter. Therefore the concentration is 0.56 grams per liter. So this question was very simple. Automatically we had molarity. Remember, molarity is measured in moles per liter. So what we are supposed to do, just to change the mole into grams, then per liter, because this was the concentration in 1000 grams, and again 1000 cubic centimeters, and again still per liter, that is also 1000 cubic centimeters. Are you there? Good of you. Now let us get another example. So molarity is very simple. Only the things that govern molarity, that is to read a question, you understand a question, write the correct formula, then get the conversions well. Okay, let us get another example here. Example number 4. Now example number 4 says calculate. It says calculate the mass of nitric acid required to make 200 cubic centimeters of a 2 molar solution. When you see this, what comes into mind? This is concentration. You first pause and you give this one, you put this one into interpretation. This means that in 1000 cubic centimeters of a solution, there are 2 moles of a substance. And what is that substance? The substance is nitric acid, of nitric acid, and this is the formula of nitric acid there. Then you continue. Then now the question says a solution of calcium iodide. No, this question was wrongly said. So no, this question was combined. Sorry, it is combined question. This one says calculate the mass of nitric acid required to make, right? Now, so from here the interpretation, we have put this one into interpretation. Then we are coming to the question. Calculate the mass of nitric acid required to make 200 cubic centimeters, meaning that 1000 cubic centimeters of a solution, we have 2 moles of nitric acid. Now let us lower it and get to know. If I just remove a portion, I just get 200 cubic centimeters of that solution. How many moles of nitric acid are going to be there? Now that will be 200 cubic centimeters all over 1000 times 2 moles of nitric acid, HNO3. That is cubic centimeter is 0 by 0 is 0 by 0. Then we have 2 out of 10 times 2, then by 2 1, then by 2 5. That is 50 times 2. Now let us use a calculator here. This one says 50, that is 1 divided by 5, then equals to times 2. We are getting 0.4 moles of nitric acid. But now this one is in moles. Now what do we want? We want these moles to be in mass. We need to take this one into mass using our leading statement. What is that one? That is 1 mole of a substance. Now which substance is that one? Nitric acid is equivalent to its relative formula, mass. Now that is our leading statement there. Okay, so let us first get the RFM of nitric acid. We have hydrogen, we add there nitrogen, then plus 3 oxygens. Hydrogen is 1, nitrogen is 14, and oxygen is 16, but there are 3 atoms there. Now we have 15 plus 48. Let us add. This 48, now some people can be wondering, this 48 3 times 16, that is 48. Now let us add 48 plus 48 plus 14 there, then plus a 1, which is now 15, right? Is giving us 63. So there are 63 grams. Therefore, we come here and write and say 1 mole of nitric acid is equivalent to 63 grams. Then how about 0.4 moles? Those are the moles of nitric acid in how many? In the 200 cubic centimeters. They are going to weigh in terms of mass. It's going to be 0.4 out of 1 times 63. Now this is going to be 0.4 times 60 what? 63. The answer is 25.2 grams. So there are 25.2 grams of nitric acid containing in the 200 cubic centimeters of nitric acid. My dear learners, are we there? Are we still there? Alright, that is very good. That's good of you if we are still moving together. Now let us look at this other question which was combined with this quick example 4. The question was saying a solution of calcium iodide was made by, okay, let us first leave this one. Let us first get another one which is clear, then we shall come to that one later. So this one says calculate the concentration in moles per liter of sodium chloride containing in 5 grams. Calculate the concentration of, sorry, let me first clear this question. Calculate the concentration in moles per liter of sodium chloride containing calculate the concentration in moles per liter of sodium chloride solution containing 5.8, sorry, this was an error. This is 5.8 grams 5 grams per liter in this is not right, in 250 cubic centimeters. So now we need to get the concentration in moles per liter. Now here concentrations in moles per liter, they're asking for molarity, right? Now here they have given us concentration. Now this concentration is in 1000 cubic centimeters. Now so we need to first understand this. This is 5.8 grams per liter. Now this is our concentration. Now this is the mass in 1000 cubic centimeters. So we have to first get that mass. Then after getting the mass, then we can also get the concentration in moles per liter. That is in 250 cubic centimeters of that solution, just like that one. Okay, now what is the substance? The substance is sodium chloride, so this is sodium chloride. Now 1 mole of sodium chloride is equivalent to its relative formula mass, right? Let us first get its relative formula mass, sodium plus chlorine, and then we have 23 plus 35.5 there. Now we are going to get 0.5. This is going to be 58. This is 58.5 grams. We are going to get 58.5 grams. Therefore 1 mole of sodium chloride contains or produces 58.5 grams in mass. Then if now we take the leading statement, we change it because we're changing from grams to moles. This will be 58.5 grams of sodium chloride will produce 1 mole. Then how about these ones here? Then how about 5.8 grams of sodium chloride. Now don't get bothered per liter. This means that that mass is in 1000 cubic centimeters. So don't get bothered at how about the liter, what are we? No. Don't get confused. Leave the liter there. You extract the mass. You get what is in that water, that solution, that solvent. Okay, now this will give us now 5.8 grams divided by 58.5 grams times 1 mole. So this is going to give us my calculator, where you, so this is 5.8 divided by 58.8, right, is equal to, now this is giving us 0.0986. Let us take that one, 9.86 moles there. Now this one is now the molarity. So the molarity is now going to be 0.0986 capital M, or moles per liter. Now this one we are going to take to get this one, and again we compare it with the DC volume given. That is now going to be, now in 1000 cubic centimeters of a sodium chloride solution, there is 0.0986 moles. Then how about if I just remove 250 cubic centimeters of the sodium chloride solution here? Then this is going to be 250 cubic centimeters out of 1000 cubic centimeters times 0.0986 moles. Then this is going to give us now my calculator, this is 250 divided by 1000 times 0.09, where is 998 and 6. Answer is 0.024 moles, right? Now so therefore the 250 cubic centimeters of sodium chloride solution contain to 0.024 moles. Let me hope that we are still together. Let us do another example. So this other question says calculate the molarity of sodium hydrogen carbonate. Calculate the molarity of sodium hydrogen carbonate solution containing 2.1 grams per liter. Oh, this was a typing error here. There is a point, sorry. Grams per liter. Now what comes into your minds automatically when you see this one? Now this is concentration. Obviously concentration, they are matching with the molarity, but the difference is molarity is in moles, concentration is in grams. So what is required of you to change the grams to moles? And how would we change? Using our leading statement. And what is the leading statement? 1 mole of a substance. Now in this question, what is the substance? That is sodium hydrogen carbonate. Then 1 mole of sodium hydrogen carbonate is equivalent to its RFM, that is relative formula mass. You get the relative formula mass, then you convert from moles to mass to moles. Okay, let us first write our formula for sodium hydrogen carbonate. This is sodium hydrogen carbonate. That is sodium hydrogen carbonate. Now if this is our sodium hydrogen carbonate, it is in a solution, and okay, let us take this one, sodium hydrogen carbonate. Let us change. Let us first write the leading statement. 1 mole of sodium hydrogen carbonate is equivalent to its RFM. Now what is RFM of sodium hydrogen carbonate? Sodium, then plus hydrogen atom, then we have 1 carbon and 3 oxygen atoms. Now we have 23, then plus 1 plus 12 plus 48. Where is this 48 coming from? The 16 times 3. Now let us compute using a calculator here. This is going to be 23. 23 plus 1 plus 12 plus 48, we get 84. So this is giving us 84 grams. Therefore 1 mole of sodium hydrogen carbonate is equivalent to 84 grams. Now let us change the leading statement. That is 84 grams of sodium hydrogen carbonate in terms of moles. That is 1 mole. Now how about 2.1 grams of the sodium hydrogen carbonate? There it will be 2.1 out of 84. Remember we are using inverted L. So this is let us compute. This is 2.1 divide by 84, then times 1. Obviously this is giving us 0.025 moles. Therefore our molarity is very simple, because now these are the moles, and these moles they are equivalent to the mass which was in 1000, and therefore this is automatically the molarity. So therefore now our molarity is 0.025 moles per liter. Alright, my dear student, I welcome you. I thank you once again for choosing Revision Uganda. This is chemistry. So chemistry is very simple, and we are taking that bit of chemistry whereby some members think it is very difficult to do. This is molarity. No, it is not difficult. Give it time. So play this video over and over, again and again, and for any misconception, any misunderstanding, any confusion, please, our social media platforms are already open for you. Please contact us. You can WhatsApp us, you can send us an email, you can visit our website, you can leave your comment, you can leave a question. Please, together we are providing the education in its simplicity. Yes, this is molarity. Chemistry is fun. Please feel relaxed. Be relaxed. Feel free. Ask. Yes. Okay, let us now do the last question of this, our first segment. This last question is very simple. Says, calculate the concentration in moles per liter. Listen. Calculate the concentration in moles per liter of a solution containing 0.4 moles of sodium hydroxide dissolved in water, and the solution is made up to 100 cubic centimeters. Very simple. This one is very simple, meaning that these 0.4 moles, they are in 100 cubic centimeters, right? It's like now when you have your container. Now this container, you have water, then you put the sodium hydroxide, you dissolve, and that sodium hydroxide you have put there is equivalent to 0.4 moles, and now you make it to be 100 cubic centimeters. Then after there you say, let me add there small water to make it a liter. So the more you dilute, even the moles do also dilute themselves. Then that is what we are looking for. That is molarity. It's like when you're having sauce at home. When now the salt is too much, then you start adding there water. Then the sourness or the salty thing reduces. The salty taste starts to reduce, right? This is at home. This is at home. Molarity at home. Then meaning that now as you keep on adding water, then the molarity, the concentration is reducing. Okay, which you call, now for us, our concentration, we are looking at the concentration at a liter level. Okay, and now those people who are making sodas, making juices, what, so they use the concept of molarity, and when they're making drugs, they use the concept of what? Molarity. Okay. Now let us get this question and we fight with it. Okay, let us not fight with it. It's very simple. This one says, in 100 cubic centimeters, how many moles do we have there? But my dear learner, you have to write sentences, right? In 100 cubic centimeters of a sodium hydroxide solution, there contains 0.4 moles, right? Then how about 1000 cubic centimeters? Because the question is asking concentration in moles per liter, automatically what comes into your mind? Molarity. Molar of now sodium hydroxide solution. This will give us 1000 cubic centimeters all over 100 cubic centimeters times 0.4 moles. Then 0, 0, 0 with the 0, so we have 10 times 0.4. Then this is 10 times 4 out of 10. Even if I don't use a calculator, right? 10 by 10, I remain with 4 moles per liter. Yes, I remain with 4 moles per liter. My dear students, thank you for choosing Revision Uganda. This one marks the end of our first chemistry lesson under mole concept, molarity as the subtopic. We meet in the next lesson, but remember, down there we have the activity for you. Try to do it. Try to see if you've understood. If you have not understood, go back to the video, repeat, play it. If again you're not understanding, please WhatsApp us, call us, send us an email. May God bless you.